Hello, great Indians. My name is Hitesh Kishnani, mathematics teacher, Great India School, Raipur, Chhattisgarh. So previously we have studied about the irrational number. We have seen 2-3 examples, root 2, root 3. We have represented this irrational numbers on the number line. Today we will start with the new topic, that is a terminating and non-terminating decimals. So let's start. So students, this is our topic, that is the terminating and the non-terminating decimals. So first of all, we will see the classification of the terminating and the non-terminating, that is a classification of decimals. So basically this decimal expansion is basically classified into two categories, that is a terminating and non-terminating. Non-terminating is again classified into the repeating and the non-repeating decimals, right? Terminating decimals are sure short, they are the rational number. When we talk about the non-terminating, if it is a case of a non-terminating repeating, then it is a rational number. If it is a case of a non-terminating non-repeating, then it is an irrational number, right? So decimal expansion are basically classified into two categories, terminating and non-terminating, and non-terminating are again classified into the repeating and non-repeating. So right, so terminating decimal expansion and non-terminating repeating, these are rational number, but non-terminating non-repeating are always a irrational number. So let's see one by one with the help of an example. So first of all, we'll start with the terminating decimal expansion. When we talk about the terminating decimal expansion, terminating means when the decimal expansion terminates or end after a finite number of steps. It means when we divide some number by some integer, right? If the remainder is 0, if it stops after some steps, then it is called as a terminating. Terminating means stop, right? So let us take an example. If we divide 1 by 4, okay, after some steps the remainder will become 0 and the question is 0.25. So if the remainder is 0, then it is called as a terminating. If the remainder is not equals to 0, then it is non-terminating, right? So what is the definition of the terminating? When the decimal expansion terminates or ends after a finite number of steps. End means when the remainder is 0. So when the remainder is 0, 100%, it will stop at that process, right? So terminating, the definition, this is the terminating definition, terminating decimal expansion definition. This is the example. So let's see some more examples on the terminating. If we divide 5 by 8, when we divide 5 divided by 8, okay, so when you start the division process, right, so after some steps you observe that the remainder is 0, right? So if the remainder is 0, then it is an example of the terminating decimal. So what is the question? 0.625. Here the remainder is 0, that's why the question is the final answer, right? So after some steps, if the remainder is 0, then it is called as a terminating decimal expansion, right? Now let's see, talk about the non-terminating decimal expansion. When the decimal expansion does not terminate or repeats, right, it means that when the decimal expansion does not terminate or repeat is called as a non-terminating. So in other words, if the division process does not end, it means that if the remainder is not equals to 0, then it is called as a non-terminating decimal, right? So if the remainder is not 0 and if the division process goes on continues, right, then it is called as a non-terminating decimal expansion, right? Let's see some examples based on the non-terminating. If you divide 2 by 3, you get the answer 0.6666 and so on. So if this 666 are repeating, then that's why it is called as a 0.6 bar, right? When we divide 3 by 11, then you get 0.2727. If 2727 are repeating, that's why we can write it as a 0.27 bar. When we divide 11 by 6, we get 1.8333. Here you observe that the 3-digit 33 is repeating. That's why we can write it as a 1.83 bar. So these all are examples of the non-terminating repeating. Non-terminating repeating. That's why these all numbers are the rational number, right? These are the examples of the non-terminating non-repeating. When you talk about the value of root 2, its value is 1.4142. Here you observe that no digits are repeating, right? That's why it is an example of non-terminating non-repeating. Here remainder is also not 0 and the digits are also not repeating. When you talk about the root 3 value 1.732000, so on, right? Here also you observe that the digits are not repeating. That's why it is an example of non-terminating non-repeating. Value of pi is 3.1415. Here also the digits are not repeating and remainder not 0. That's why these all are the examples of non-terminating non-repeating. These are examples of non-terminating repeating. So here it is a non-terminating non-terminating repeating. That's why this is a category of a rational number and these are the categories of the irrational number, right? We have already seen in the classification of the rational number. So here students, we will talk about the decimal expansion of the rational number. We will not talk about the irrational number. Let's take an example, 7 by 8. When you divide 7 by 8, you get the remainder 0, right? After some 2 to 3 steps, you get the remainder 0. That's why it is an example of the terminating decimal expansion. When you divide 10 by 3, you get the answer 3.33. Here the remainder is not 0. Okay, division goes on continuously. That's why this is an example of non-terminating repeating, because here the 3 digit is repeating. When you talk about the, when you divide 1 by 7, you get the answer 0.142857, right? 0.142857. Again, after some digits, this 142857 is repeating, right? When you divide, when the division goes on continuously, here the number of digits are repeating. Which numbers are repeating? 142857. This whole string goes on repeating. Here only single digit was repeating. Here the more digit, the string of digits are repeating, right? So in the decimal expansion, two cases arises. The remainder is equals to 0 or the remainder not equal to 0. If the remainder is 0, then it is called as a terminating. If the remainder is not 0, then these are the cases of the non-terminating, right? So this is the case number 1. Then when the remainder is 0, then it is called as a terminating, right? And this is the case number 2. When the remainder is not 0, then it is called as a non-terminating decimal. This is the example of non-terminating repeating are sometimes called as a recurring. So basically in the decimal expansion of the rational number, two cases are there. If the remainder is 0, then it is called as a terminating. If the remainder is not 0, then it is called a non-terminating repeating, because we are here we are going to deal only with the rational numbers, right? So rational number having two cases, terminating or non-terminating repeating, right? So decimal expansion of the rational number have only two choices. One is terminating and second is a non-terminating repeating. So we have to identify whether these numbers are terminating or whether these numbers are non-terminating repeating.